Okay, so lesson 2 in polynomials. So far, we have learned to describe them by degree and by the number of terms and to put them in standard form. So now you are going to learn how to add and subtract them. Okay, biggest thing about adding and subtracting polynomials is that you are basically combining like terms, which you've been doing for a good while. You need to make sure you put your answers in standard form when you're done, right? When you've combined all your like terms. And as a reminder, okay, like terms have to have not just the same variables, which is probably what you were doing in middle school, but they also have to have the same exponents on those variables, okay? So take a look at some examples I've set out. So 3, and this is read as 3x squared y, and negative 2x squared y are considered like terms. Take a look. They both have an x squared. They both have a y. So you would just, if you were adding them, you would be adding the coefficients, 3 and negative 2. If you were subtracting, you'd be subtracting the coefficients, 3 and negative 2. Okay, so the only thing that ever gets changed when you're adding and subtracting are the coefficients only. Okay, but you have to check the variables and the exponents to make sure that something is considered like terms. So 4x and 6xy are not like terms because this one does not have a y. This one does. 5x squared and 3x are not like terms. This one has a squared, highest exponent of 2. This one only has a highest exponent of 1. Okay, so not like terms. Now, what we're going to do is we're going to go through our polynomials and just pull out all of our like terms and then combine them. Okay, so I've got several examples to go through. So let's start with adding. Okay, so here we have a polynomial statement that is being added. Right, see addition between them. So we're just going to pull our like terms out. And I always start with whatever is the first polynomial and whatever is the first term, no matter what order they're in, just so I can go through and make sure I get all of my like terms, all of my possible pieces. So here, my first term is 4x squared. Okay, and I'm adding, and I need to check to see if there is another like term, another x squared that needs to go with it. Okay, there's not, so that is grouped by itself. Okay, so then I go through and all right, now I need to go to the next term. So my next term is negative 6x. And again, I need to look for all of the pieces that just have an x. And there's the other piece. And again, I'm adding. So I'm adding negative 6x and 5x. I've grouped my like terms. Okay, so go to the next piece. The next piece is a 2. That's a constant, right? No variable. And the other constant is negative 3. So I'm grouping 2 plus negative 3. And I'm remembering that I am always carrying my addition symbol with me because that's what I am doing. I am grouping. Okay, so then I just go through and actually combine my like terms. This one's fine by itself. Okay, and then again, I'm combining by just working with the coefficients. So it's negative 6 plus 5. And negative 6 plus 5 is negative 1. We don't have to put the 1 in front of it. You can if you like. It's not considered wrong. Okay, and then the last piece, 2 plus negative 3 is also negative 1. And we're already in standard form, so we're good. So that's it. We have added these two polynomials together by combining like terms. Let's try another one. And again, specifically, I put this one not in standard form just so that you can see. It doesn't matter how it's set up as long as you combine your like terms and then put it in standard form when you're done. So first term is 3. That's a constant, right? No variable. Okay, so go along, find the other constant term. Okay, so I am adding 3 and 2. First set of like terms grouped. And again, I do this in different colors just so that I can show that all of my pieces are grouped. You can mark them off as you go if you want. That works too. All right, so my next one is negative 6x squared. And there are no more squareds. Okay, so that's just by itself. All right, and then the next piece is a positive 7x and a positive 14x. I'm just going to put them together since they are being added. Okay, so everything has been grouped. Go through and combine your like terms. Okay, that's 5. That's negative 6x squared. And that is 21x. So now I just have to write it in standard form, right? The highest exponent first. So that means the x squared goes first. And you should, hopefully, when you were working on integers back in middle school, possibly elementary, if there's no symbol in front of something, it's automatically a positive. I do have to show that when I put it with something else. Okay, and that is in standard form. And all of my pieces have been combined, and there are symbols that represent the separate terms, and we're all good. All right, so let's try a couple subtraction ones. Okay, so very specifically, and again, you should have learned this when you were first working with integers, we don't actually subtract. We call it, I know sometimes in middle school they said keep, change, but basically what you're doing is you're changing the subtraction to addition, and then you are going to change all of the signs after it. So you're either distributing, multiplying basically by the negative, because that could be thought of as a -1, or you are adding the opposite. So you have to change all the signs that come after the subtraction sign that you've changed. So basically, this will become, oh, why is this being silly now? Okay, so there we go. 4x squared minus 3. Okay, that becomes addition, and everything changes. So the 2x squared becomes a negative, and so does the 7. Okay, so now it's rewritten as an addition problem, and then we are going to treat it just like we did the last ones. We're going to combine our like terms, so we're going to group them together. So again, first term is 4x squared, and the piece that matches it is a negative 2x squared. And we are adding now, right? That's why I've got the addition symbol there. All right, next set of like terms is a negative 3, and I'm adding a negative 7. Okay, so same thing we did before. You've now got them grouped. Go ahead and combine your like terms. So you're adding 4 plus negative 2. That's 2x squared. Okay, and then you're adding negative 3 plus negative 7. So that's negative 10. You can also write that as plus a negative 10. That does mean the same thing, right? So hopefully you remember back from, again, your integer rules that plus a negative is the same thing as subtracting. All right, so try the next one. Okay, and again, first I'm going to rewrite it as an addition problem. Okay, when you start working on the assignment for this, I expect you to show this step. It's a very important step, and a lot of people mess up because they forget to write it down, and then they forget that all those signs had to change. You know, it's very easy if you don't rewrite it like this to make this a minus, make it a negative, but then forget to change the other sign. So I'm going to require you to rewrite it like this. All right, so now let's go ahead and combine our like terms. We've got 6 constant term. Okay, go all the way down, and we've got a negative 2. don't know why the board is being weird. There we go. So 6 plus -2, that's the first one. All right, and then we have -4x squared. And go through, and that would be a positive 3x squared. All right. And then we've got a positive 3x and a negative 7x. Okay, so now we're just going to go through and actually combine our like terms. So that's positive 4, 6, and -2. -4 plus 3 is -1. So again, if you want to write the one, you can. If you don't, it's not a requirement. And then you have 3x, or 3 basically plus -7. So that's -4x. So now we just need to make sure we've got it in standard form. Again, highest degree first. And then the next one. And then the last one, since that is a positive 4 at the beginning there. Okay, so that is lesson 2. And again, start on the assignment for that one. And when you are done and you feel like you have it good, then we should be able to move on to lesson 3.